Hello friends, welcome to Fox Tech. So today we're going to see the new topic related to the Kubernetes network, and this is moreover about how to optimize your cost. So let me jump into that video. So anytime if you are working on a Kubernetes, feel like my application is slow or this is something like whenever I request something and it's taking long time to pass the data, so this could be not only due to the application, so this also possible it's due to the networking. How networking will be a key reason here. So before we jump into that, we should understand the basics. When you are when you are deploying your Kubernetes cluster into the cloud what it does, so it's spread your cluster into multiple zones. So why we need a multiple zones? It's mainly for the redundancy and scalabilities for the grid strategies, right? But when you have a torrential traffic routing can cause inefficiencies. How? So let's assume like your pods are communicating across the zones. The zones are a little bit far away and it takes a time to process your request. It's like if you are going into foreign or somewhere, any other country from your native countries, so you lost somewhere. So what happens? Obviously, it takes time to reach the any location and may sometime we have to pay for the costing as like that even in the cloud. So when you are doing the cross zone communications, we need to pay for the egress cost, right? So this is could be a reason. So your application may be slow and your requests are taking more time. How you can fix this? Right. So there is a solution. It's introduced on 1.21, I believe. So it's called topology hour routing. So what is this topology hour routing? Topology hour routing is a Kubernetes feature that optimizes the network traffic flow by considering the physical and or logical layout of the cluster infrastructure. With the TAR enabled, the Kubernetes can make informed routing decisions to prioritize keeping the traffic within the zone it originates from. This reduces the latency and improves the performance and potential minimize the network egress cost. As I mentioned, so this is all the advantage about TAR. So how this works? So here little bit we have to go deep. So this has a four layers. The first process called pod communication. Pod within your application communicates with each other through the services. As everyone knows, those services act as a load balancer, directing the traffic to the appropriate pods based on the selector or labels. So this we know well how the service works, and this so the tar uses, but additionally it has two more points. The next one it adds called endpoint slices. So when the service got created and Kubernetes create, it's called endpoint slices. So I'll show you what is the difference when you create a normal service and with a tar. I'll show you the difference. So the what is endpoint slices by the by? So which essentially the service endpoint informed by the divided by the zones, right? So this endpoint slice contains detail about the pods that belong to the service and including their zone locations. That's key reason. Key data it contains. Then there is one more detail. It's called topology hints. I'll show you that also in my example. This endpoint slice controller is incorporate the zone information into topology hints. Those ends are attached to the endpoint slices. So it has a correlative and indicating the preferred zone for the endpoints. So if any endpoint comes, so it help you to pick, hey, this pod is coming from this zone, you should choose this particular zone, so it will be a more efficient, right? So that's called topology hint. And when you have all this information, obviously our kube proxy, it's easily schedule your pod, right? So kube proxy, what it does, the network proxy running on each node, utilize the topology hints when selecting the endpoints for the service traffic. It prioritizes selecting the pod within the same zone as requesting the pod whenever possible. Well, so it's very cool, right? Right. So what else it does? So before we jump into the example, so I like to give you the one more detail. It's called benefits. So what is the key benefits on the topology of a routing? The Reduce latency is the first and foremost. By keeping the traffic local, tar minimize this distance packet need to be traveled and resulting in faster communication between the pods, right? And improved performance when you lower your latency translate to the more responsive and prominent applications, right? So when you have this and you are already saved your network cost because you are not traveling for long distance, you are traveling within your zone, so it will be having a cost optimization benefit also. So when you see your applications are leaking a lot of network cost, you can check this feature again. So you have to talk to your architect or you have to see your application architecture. Based on that, you can choose this. Tar maybe have a lot of drawback. I will explain you end of the video. Before that, let's jump into the example. So the in the example, what we're gonna cover. So let's assume we have two region. One is US East A, 1A and US East 1B. And we have two applications or the deployment contains two parts. The deployment name is Fox App 1, Fox App 2, and Fox App 1 has two container, container 1 and container 2. Fox App 2 has two container again. And let's assume the Fox App 1 container 1 like to communicate to Fox App 2 container 2 all the times. But even the both the containers are almost doing the same work. Why do you want to communicate to the cross region, right? So by general, if you are not enabling the tag, Kubernetes service doesn't bother. What it does, randomly it picks up containers and it will just send the traffic to the any containers. So what happens with this? You may need to incur the latency issues, you may incur the cost, or you may face some slowness in your applications. So how you can optimize it? So there the tar comes. What it does, it will make sure it won't do the cross communication, but it help you to communicate within your zones. So how you can do, I'll explain in the next the demo. So the demo is on now. I have already the files created. So let me quickly show you my deployment files for your reference. It's a very basic one. So it's a basic one with the app one selector and it doesn't have any other container port or something. But my second application will have you the container details because we're going to expose this service outside and show you the details, right? So let's quickly deploy this. Sorry for this. Well, let's check. We got a bots, right? My bots are running, and let me show you my service file, which I'm trying to expose it. To this should be to service, yes. So I have this service file. Again, it's a very basic. I'm choosing the container port of 80, which I shown in the deployment tool. I'm going to deploy this kubectl apply XNL app v2. Sorry, my server is little slow today. So I'm applying my service font. So let's quickly check my font and service. I'm applying everything in the default namespace. So please check when you are applying this. You may need to use your own namespace. So as this is a demo, I'm using my own default namespace, right? Okay, so my pods are running. I have the service there. So let's describe the service and see once what will be the difference. As we seen in the how the tower works. So when you describe it, you may see very basic details. You may not see a lot of details, like it doesn't have a topology hint or anything. So I'll show you that. You may see a lot of time, but I'm just going to show you once for this video. So this doesn't have any other details. So what I'm going to do quickly, I'm going to apply the topology details. So tab for the same service. So what I'll do, just I'll modify the changes which I commented. Okay, so let me explain what we are doing here. So we have to add annotations and service Kubernetes IO. The topology mode should be set to auto. So when you do so, let me quickly save this and I'll apply the service file. Well, so the service file is applied. Let me quickly describe it and you see the different details. So you can see this here. So you have a topology hint I got added. Unfortunately, I may get this error because I don't have multiple zone or multiple details. It's like a very basic server. So I may get this error, but when you have running your multi-zone network, you may get a message. It's saying that the topology aware hints has been enabled. So that's the key detail you will get on from the endpoint slice controller. So let's quickly check endpoint slice also. So describe the endpoint slices to yes, we see. I will just put this detail. Okay, that should be Fox iPhone. Well, right. So you can see the name of the service here. So the name of the service is Foxito and namespace is default, and you have managed to by the endpoint slice controller. So this is the container it's managing, and it has a detail about the port and what are the endpoints. The endpoint contains detailed things like addresses, which address it's using, is it ready or is it a false or whatever the status, and host name. If you set, it will be coming here. Target reference, so what is a pod I should refer, and node name. If you have a multiple node, you may see the different nodes. So even I'm seeing it here, two nodes, one is on the 5, one is on the node 6, right? But unfortunately, my both the nodes are in same region, sorry, same zone. If you are running with a multi-zone cluster, you may see that the zone will be different. So please note that mine it's a single zone cluster, so it's for the demo purpose I created. So that's the reason I may see with a single zone. But when you see in your Kubernetes cluster, it can be a multiple one and you can pick it up. Otherwise, you can filter from the Kubernetes node command and with the topology, you can sort it out. Right, so I have two nodes and I can see both are scheduled and I can see the endpoint slice details here. And as I said, my service also exposed well and I got the detail about the endpoint slice and also the topology hint, which says that my node is not yet ready for that. But if I have a multi-zone, so it will be ready, right? So you may ask what happens. So let's go back to the slide. Let's assume you have only one pod in the deployment. The replica, unfortunately, you set to one, or your application can support only one container. So what happens? So for that, you can't enable this tar. Tar can be usable when you have a multi containers and the multi-zone enabled, right? Within a zone, it obviously doesn't need for just for your information. And even the one deployment having a two replicas and another one having a one replicas, even that's not suitable because unfortunately, when the request comes, it always has to go with the only one container, right? Hope this gave you the enough information about the TAR, how you can enable and how it works. Now let's understand the drawbacks. This is a key things to understand if you like to use the tar in your production or production equivalent environment. So you should avoid the drawbacks or the limitations always, because that help you to decide should I use this tool or not, right? So let's know about the drawbacks or the limitations. Tab, it offers a performance and cost benefits, but it comes with some drawbacks. What are the drawbacks? First, it's reduce the reliabilities. By keeping the traffic within a zone, tar can limit your ability to recover from the failure in that zone. So if all the pods serving to the service in the same zone, if it goes down, your service become unavailable. So when you are picking on the production, so please keep this in mind. You should be well aware about this. I may recommend if it's a critical application, you should not use tab. It's my personal recommendation. So you again, it's up to you to choose it. Why? Because if the application is down, if the critical application is down, you may has to your customer may lose the interest, and they may lose your you may lose your credibility with your customers, right? So concerning everything, so always keep it that in mind. Production, rethink about it when you are enabling a tab. But I may prepare for the non-production workloads. You may have multiple non-production workloads, dev, test, pre-prod, or whatever it's called in different organizations, right? There you can enable this. That may help you to reduce a lot of cloud cost. Next, scalability limitations. Sorry. Managing the complex routing rules for each service within many pods across the zones can become a cumbersome, obviously. Computationally expensive, mhm, especially it's a large cluster. So when you're having a large cluster, please check this drawback and choose wisely. Sorry. Uneven the traffic distributions. So always star assumes the traffic originated roughly from the proportional to the capacity of its zones. This might not be true. The leading to the single pod receiving all the traffic in the zones, it's a potential bottleneck. So again, it's equivalent to the first one. Service may go down due to this also. If every traffic is coming to the single pod, your pod may not respond properly to your customers, or when you may face some kind of a slowness. Let's assume like you are hitting some API call that's taking a long time to respond. This could be another reason. So network can be a big player in that. So this kind of a problem also may arise there. And it has a limited functionalities. So TAR doesn't work well with the service with the most traffic coming from the specific zones. It's again correlated. Or when the internal traffic is set to local within the service, TAR won't work, right? So this may give you the drawbacks about the tar. So it's always good to know about the drawbacks. So overall, the tar is valuable tool for optimizing the performance and cost, but it's crucial to consider the limitations and understand your specific traffic pattern before you're deploying it. So yeah, so please understand your traffic's patterns, what is the flow and how it works, and where is your cost is leaking, or where is your latency issues, where you are facing the actual issue. So based on that, we recommend you to choose wisely for your application, the TOR or any other suitable solutions, and design your architecture. Right? So hope you learned something, guys. If you like, please share this video with your friends. If you want us, if you see any implementation, so please feel free to share it. So it will be good for us to improve our side, and we can bring more topics for your reference, and we can explain you well. Right? Thank you, guys. Thanks for your time. Have a great day. Bye.